Welcome back to our channel, Women Eugene. As we have seen last time, we have did for the power factor correction, and today we're gonna continue working on it in another philosophy. For this day, we have a three-phase 50 Hz 400 motor developed 100 horsepower. The power factor being 0.75, lagging an efficiency of 93. A bank of capacitor is connected in delta across the supply terminal, and the power factor lies at 0.95 lagging. Each of the capacitance unity is built in 4 similar 100 volt capacitor. We are required to determine the capacitance of each capacitor for those installed. So for better, let's break down. Before we proceed, we must know what we are required to do. We have to search the power that the motor is taking. Once we get the power, we are going to search the apparent power. So let's begin with taking the data. We have the power of motor, which is equal to 100 horsepower, which is not the normal unit of measurement. You need to go to kilowatt, and you know 1 horsepower, it is equal to 0.746 kilowatts. The power of motor will be equal to 100 times 0.746 kilowatts, which will get 74.6 kilowatts. And this motor, it is working on the 93% of it. So let's see the power dissipated. So that the power in will be equal to 74.6 kilowatts divided by 0.93, which will be 80 kilowatts. For now, we got the power, and we have the power factor, initial power factor initial, which is equal to 0.75 lagging, and we have the power factor, which will be final. The one will go to, which is equal to 0.95 lagging. Let's find cosine of the theta 1. Let's call AB 0.75, and theta 1 will be equal to cosine minus 1 of 0.75, which will be equal to, for this, will be equal to 41 degree. For this, let's search tan theta 1, which will help us to put the active power to the reactive power, which will be equal to tan of 41 degree. It is gonna be 0.8819. We keep up, continue for working for this power factor. Cos and theta 2 will be equal to 0.95, where theta 2 will be equal to cosine inverse of 0.95, which will be equal to 18.194 degree. So that for this, let's continue find tan theta 2, which will be the tan of 18.194, degree, which will be 0.3286. Now for this, to use this, remember we have the active power in kilowatts. Let's call this point initial. And now we have reactive power for the theta 1 kilovolt amp kVA 1 corresponds to theta 1. But for when we improve the power factor to theta 2, we have kilovolt amps 2. This is one after operation. And let's join these. For getting, that's the OA, let's call B, and that is called C. Now, what we need to know, it is the reading, it is the consuming reactive power corresponding to B and C. Let's look for this philosophy for the first. If you see BC will be equal to AB minus AC. Now, for transposing this apparent power to this B reactive power by applying tan, for this, if you see this line corresponds to KVR for angle for the power factor 1, while for this it will be the KVL for angle 2. But how will we gonna get this and this? KV, the reactive power for 1 will be equal to, will be the power, active power in kilowatts, that is power tan theta 1, while for KVR 2 will be equal to power tan theta 2. Now the difference of the two will be what a capacitor bank will consume, so that to improve the power factor. Let's clean so that we continue. Now the reading reactive power consumed by the condenser will be equal to the difference BC, which will be equal to BC, AB will be equal to power tan theta 1 minus power tan theta 2. Now, put in evidence P, now make tan theta 1 minus tan theta 2. For this, we proceed now. That is 80 kilowatts as usual, times 0.8819 minus 0.3286, which will give us, this will give us 44.264 kVAr. That is the power factor the whole condenser will consume. But it is in delta, it is in sum. So we have to search the reactive power will consume by a condenser per phase. So that we have for this 3 phase, we have to divide by 3. Now, we continue reading KVR. Per phase will be equal to 44.264 kVAR divided by 3, which will be equal to 14.75 kVAR. Now, what we need to know, for that this will be connected together, we have to search the first current. Now, I capacitor per phase. This will be the current that will correspond to the current drawn by consumed by the condenser. Let's go. We have to remember the current will be equal to the V per phase over XC. And remember, XC is equal to 1 over CW. Now for this, where CW is equal to 2 pi FC. And now IC per phase will be equal to V phase times will be the inverse 2 pi FC. Now IC per phase will be equal to, we have 400 volts from the previous equation stated, times 2 times 22 over 7 times 50 times C, where C it is the capacitance. 125,600 C ampere. So what you see now, we have C in terms of current. Now we're gonna search the kVA per phase. kVA per phase. We're gonna take V times C. Remember, V phase times ICP will be equal to the kVAR. Now, if this given, that will be here you have to divide by 1,000, which is equal to 400 times 12,5600 C divided by 1,000, which will be equal to 5024 C. Now, this will be an equation number 2. Taking equation 1, equating with this, we'll get the value of C. Now, 5024 C will be equal to 14.75. C, the value of C will be equal to 14.75 divided by 5024. C will be equal to 293.6 microfarads. For this value, it will be, if you remember, will be 4 capacitors. Capacitors put in series achieve the 4 identical and which make which will provide the required reactive power that we consume. So for this to get the required, we have to take the single unit times the number 4, as it will be in series. Now, since it is combined in series, we have 4 similar capacitors. The required capacitance will be equal to 4 times 293.6 microfarad, and now C will be equal to 1173.6 microfarad, which will be the required capacitor per phase to collect this power factor from 0.75 to 0.95. So after getting this, what we require is just put this in data during the practice. So thank you for watching today, and I hope for the next you can make a share, a comment, and what you want for the next, so that I can do for you the way you can design different parameters, either protection, either lines, all parameters I'm aware for. So just write for me and make a share and a comment and what you need for me to do for yours. Thank you for today.